So the next topic is OpenMP, OpenACC offloading BoF. I'd like to start with a short summary of what's changed in the OpenMP area and what I'm working on, and then the rest of the BoF should be discussions on how we can collaborate between OpenMP and OpenACC, and from the middle end point of view, and what can we improve together, so that we are not working on separately on OpenMP and OpenACC and not sharing anything, because that's wasted work. So the last OpenMP standard, which is mostly implemented in GCC from GCC 6 or 7 something, is OpenMP 4.5, which has been released 3 years ago. For C and C++, the support is basically complete, or should be complete, minus bugs. And for Fortran, it's partially implemented. There are some missing stuff like the mapping of structure elements. But I didn't find time to finish that. So if anyone can volunteer, that would be appreciated. Otherwise, it will be implemented at some point. So the next OpenMP standard is OpenMP 5, which is a new major version. So it took longer than usually. Usually, the time between 2 OpenMP releases is 2 years. This time it will be 3 years. The public draft has been released in July, and we have an OpenMP face-to-face meeting in early October in Barcelona, where we will meet and hopefully finalize everything, plus some voting afterwards. And so the standard should be released in November. There is some high-performance computing conference, supercomputing or something in November. So the goal is to release it by at that time. So for GCC support, there is a separate branch, GOMP 5.0 branch, which I'm working on. And the problem is that the amount of work is so huge that I'm certain it won't be ready by GCC 9. So my plan is to find out the items of the standard which are fully implemented from parsing up to runtime, and merge those into GCC 9 during late stage 1. And afterwards, I will need to do the usual bug fixing for half a year, and then continue working on OpenMP 5. So what's new in OpenMP 5? OpenMP 4.5 was limited to C99 and C++ 98, which is a little bit outdated, of course, because everyone wants to program in C++ 17 and 14. So the support for these languages is in there. For some of the language features, it means actually no changes needed, but for stuff like lambdas and structure bindings and so on, we of course need extensions. And actually the way it's implemented is there is a list also of the language features which are still not supported in OpenMP 5, but the list is quite short, and there are basically, if you use those features of the standard in some connection to the OpenMP directives, then it's unspecified what it does. But otherwise, of course, you should be able to use those language features in the same translation unit as OpenMP and get some reasonable result. A bad example, what we've done in the past was when thread local was, or no, atomic underscore atomic was introduced in C99, C11, and basically what GCC did for a couple of years was that whenever you use OpenMP pragmas in the same translation unit as underscore atomic, you got an error or sorry or something. So that's really not acceptable because you could use it somewhere else. Of course, we want to, if it's not supported, we want to error out on the directives where you exactly use it. But so for instance, what you can with the C++17 is now use the OpenMP loops like work sharing loop or SIMD or so on with structure bindings or range 4, and it should work. That's already implemented on the GOM5 branch. There is also the teams construct, which is in the past has been required to be directly nested in the target region and was used for basically like the OpenACC gang. Now is allowed on the host as well. It can be nested in a parallel, but it's meant for uses on NUMA, where the different teams actually don't synchronize together and they run, yeah, like separate threads and don't communicate together. For the loops, the changes in the past, it has to be greater, equal, less equal comparisons in the condition of the loops. And we can now use unequal as well, which is something that C++ people keep writing in their loops. There can be some selected non-rectangular loops where you have collapse multiple loops together, and the inner loop can depend on the outer loop iterator. There are restrictions, like you can do triangular or some multiplication, but you can't go wild and use some functions of that the compiler can find out, because then it's basically impossible to compute the number of iterations before the loop, unless you run the loop again before and without the body and see how many iterations you get. One thing I really don't like that much is that it allows also non-perfectly nested loops. There you can have some code between the outer and inner loop, and the standard basically says that if you do this, then it's unspecified how many times the extra code is evaluated, and you basically can move it inside of the inner loop and compute many times or do something else. A big item is task reductions. Before you could have reductions only across parallel or work sharing constructs or SIMD, but now you can actually reduce among tasks. It's unspecified how many private variables the implementation creates, so the expectation is usually that you allocate an array with as many elements as there are threads in the parallel region, and you either initialize all those private variables at the same time or lazily, and the only thing that's guaranteed is whenever some task actually touches the variable for the first time, that it's initialized by that time already. And then it basically uses the private variable it's given, and at the end of the task region it continues, and there is some point at the end of the task group or parallel region or something similar where the reduction is reduced. I have the implementation for the parsing and lowering mostly done, and now I'm working on the library implementation for this. So far I have it on paper, and now I need to code it into libcomp. Another feature is conditional last private. Last private usually works by just assigning the value from the last iteration to the original variable. And conditional last private is meant for loops where the assignment to the variable is guarded by some condition which might be false during the last iteration, and in that case you want a value from some other iteration. It's basically some kind of reduction where you reduce using a Boolean which marks you the iteration that was where the condition was met, and so the parsing again is done, and the implementation will be nasty, especially because if you have a work sharing loop and don't see the parallel, then you basically have the private variable easily available, but you need a Boolean as well, and you can't allocate it easily inside of the work sharing region, so you need to help from the library to allocate you some extra memory on the first time you reach the work sharing region and free it afterwards. Yes, so it will need changes in the library. So for the task dependencies, there are many changes, like there are iterators, which is kind of for loops. For the clauses, you specify inside of the clause, and you can say for I equals 0 to 128, depend on, and this L value expression, and this is already implemented, and it's implemented in the Gimplifier by basically computing the values of the different dependencies there in the loop and passing that to the library afterwards. Dependency objects are a way to compute the dependencies before, like say in a structure, the address of some object and what kind of dependency is it in, out, or the new mutex in, out set. And you can then use it later on afterwards in various other tasks. So it's kind of indirection for the dependencies. Mutex in-out set is a variant to the in-out where you basically allow multiple it's kind of lock or mutex that with the task with the same dependency of this kind are guaranteed not to run concurrently, but otherwise the implementation can choose when it will schedule those tasks, and it can schedule them in any order, unlike out, where basically you are guaranteed to get them in the order they are seen by the library. Another thing is OpenMP 5 introduces allocators, where in either it's OMP alloc or with OpenOMP free, so kind of like malloc and free, but you can specify various traits, like you can ask for high bandwidth memory or low latency memory or memory which is really large, or you can ask for, there is read-only memory, you can, for various stuff, for instance on GPUs. there is alignment is strangely also a trait of the allocator. So you ask the allocator to allocate you everything page aligned or something similar. And so there are library APIs. There is allocate directive, which you use, for instance, with Fortran allocate, or you can use it just to allocate automatic variables. You have an automatic array, and you use allocate directive, and it will be basically malloced or OMP allocate automatically for you and then destroyed at the end. Or allocator clause, again, for privatization request to use special allocators. For this kind of stuff, I'm not sure if we should actually implement everything in libcomp, or if it would be better to reuse some other library. Carlos gave me a pointer at memkind, which is some library from Intel which does this kind of stuff. So the problem with using another library would be that it would be either hard or soft dependency of libcomp, so we would need to. Another option is to put that library inside of GCC sources as well, or just use the system one, and if you don't have any, you would just use the default allocator and nothing else. Or that, yes. The way it's supposed to be is that OMP alloc, you ask for some allocator or the system allocator, and for OMP free, you can you need to either use the same allocator so that it's easier to find out what kind of deallocator you use, or it can use the null, and in that case, the implementation needs to find out. So basically, it requires you to be able to, from the address, to find out which allocator allocated something. So what I looked at, memkind is kind of using that already. It's used JE malloc inside and allows you to find out that way. So further changes in OpenMP 5. Meta directive is a way to add the pragmas conditional on some context. And the context can be, for instance, in which OpenMP region visible to the compiler it appears, like you can use one of the OpenMP directives if it's inside of the Teams construct, and different directive if it's inside of Perl, in another one it's inside of SIMD, and so on. There is a complex system of computing some score, and the pragma which has the highest score will win. And there is also another directive where you can select implementation of certain functions, like you can specialize some function with a special version for if you are inside of Teams, or a special version if you are inside other construct. But it can be stuff like it can specialize also if you are inside of SIMD region and some variable is considered linear inside of the loop with this linear step, or and so on. And the way it's meant to be is that, for instance, for the SIMD, that the function then gets the vector arguments instead of normal scalars, and so basically one has to know the ABI and code appropriately. For instance, Intel wants people to use the _MM interestings inside of those routines for fancy stuff. And this is not, neither of this is implemented. And the meta directive, fortunately, I managed to disallow the SIMD details to be used in the meta directive, because that would mean that we would need to have a set of the directives and keep the choice what actually it means until the vectorization, but that would be a complete mess, because the vectorization also depends on what's inside of the loop, so it's kind of circular dependency. The way it's right now written is that basically you can find out which directive the meta directive expands to, or nothing at all at parse time. But for the calls, it's basically, it will need to be some markup or something preserved until the vectorization, and at vectorization we choose which function we will actually call, depending on the vectorization. There are new clauses on the SIMD construct. Non-temporal means that basically we should expand those reads or writes to those variables bypassing the caches. And parsing is done, but not actually the lowering, so that it can do the right thing, but the middle end already has non-temporal stores and loads, I think. And the if clause is basically conditional vectorization. Right now, the vectorizer can use in some cases some condition on when it uses at runtime the vectorization, vectorized loop, for instance, based on aliasing or alignment and stuff like that. So this allows the user to specify some user condition as well. The question is how to implement this. Either we could just duplicate the loop during the OpenMP lowering and have one scalar loop and one vector loop. But the problem is that if the vectorization fails, then we have basically two scalar loops, and probably nothing else will be able to merge it together again.
Jakub, I just had a quick question. For the non-temporal store stuff, is there any discussion about total system memory bandwidth and how to manage that? It's one of those other shared resources where, for example, Intel, we tore out all the non-temporal stores in the C library core functions because it basically makes total system performance worse.
Well, this is a hint,
yeah.
and the implementation can choose to ignore it, the non-temporal stuff. But if the user writes it, it's up to him to remove it if it doesn't perform well, or the implementation can predict or something.
Yeah.
It's basically a hint that you are not going to use that variable.
Okay.
For
so
quite
it's
some
another
time,
one of these shared resources.
And you compute it somehow, somewhere, and maybe use it 1 hour later or whatever.
Yeah. Okay. Thank you.
So there is a new loop directive, which is kind of similar to the OpenACC, or kind of kernels maybe, where because so far in OpenMP you had just the SIMD loops or work sharing loops or distribute loops, or a combination of them. You could ask to the OpenMP implementation to split the loop and do some iterations across the teams, and some iterations in different threads, and some iterations using different SIMD lanes. But that's kind of a tight control from the user asking, give me this many of this kind, and this many threads, and this many SIMD lanes. The loop directive is basically saying that the loop or loop nest is independent. Iterations don't depend on each other, and and you ask the implementation to go wild and implement it somehow and do it fast, and that's all the user cares. And there are no dependencies between the iterations. Yeah. All you tell the implementation, if it's not obvious from the source, is at what kind of parallelization level you are in. So if you are at the teams level, or which is OpenACC gang, or if you are in the parallel level at the thread level, that's OpenACC worker, or if you are at the SIMD level, and there are limitations, like you can't use OpenMP APIs inside of the loop and so on, and basically do something fast. That's not implemented yet either. Some users asked to be able, in OpenMP 4.5, there are ways to use thread affinity through environment variables and APIs, ask some thread to be bound to this hardware thread and so on. And there are now new APIs and environment variables where you can actually print whenever you create a new region, print or store in some data structures how actually it's mapped to the hardware. The task weight construct now has a depend clause, which is kind of a task dependency at the end of the task wait. You wait only for some task that satisfy the depend. For the atomic construct, you can now specify many more memory modules you use for the atomics. In the past, it has been just relaxed or fully synchronized, and now you have many more options. And there is also what I will talk later on, requires directive, and through that you can specify the default for the atomic constructs. Then there is a big part which will take probably a lot of time, is that the OpenMP library is supposed to support some profilers, that's the OpenMP-T, and some debuggers accessing those and querying various features of the library. That's going to be a lot of work, and yeah, I don't know. It's probably not even on the target for GCC 10. So related to offloading, there is the requires directive where you can, for instance, say that the program will work only on shared memory, where the device has the shared memory with the host. Like, I think NVIDIA is aiming to have new hardware where the memory will be shared, and so you can say the program will work only on those, or specify other requests. There should be a way to offload also from the device back to host if you have some, for instance, printf call and you want to, or whatever, and you want to do some offloading back. And it's kind of limited right now. But for the target update where you copy data from the host to the device or back, there should be now support for non-contiguous arrays, because, for instance, for CUDA, you can actually ask for strided copying and stuff like that. Declare mapper is a way for deep copying, and there are many changes. I have another slide where I will try to explain some of the changes for the mappings, but basically it's now arbitrary L-value expressions and that can be allowed in the map clause, and there's some specification on when pointers are attached and when they are not, and what's legal and what's not legal. And if you use any members of inside of member functions, then there is automatic mapping of this, well, of what this points to now, and so on. The default map in the past was able to just ask for two possibilities, whether scalars are mapped or first privatized. Now you can do many more things to say what will happen with pointers, what will happen with structures, what will happen with the scalars, and what happens can be that you map it, or that you first privatize it, or that you don't allow it at all. So you request everything to be specified explicitly, mapped explicitly, and so you ask, for instance, for all the aggregates to be mapped explicitly and error out if any of them needs to be mapped implicitly. OMP pause resource is an API where you can basically shut down the library, or say throw out all the threads, throw out all the device mappings and so on. There are limitations where you can call it, but some people ask for it, for instance, so that they'll be able to fork, and inside of the forked process use OpenMP again, which is right now not possible because it's a threaded process, and POSIX does not like a threaded process to fork and use threads again. So this should be, yeah, now stuff more interesting to the OpenACC folks as well. So these are examples what you can and can't do now in the map clauses. So for instance, there is a pointer plus offset which should be remapped virtually to an address in like sp bracket offset bracket dot x, and so this does pointer attachment to sp. Well, starts from the end, of course, maps the array section, then maps an element. If it's not mapped, maps again some array element, and so on, and does the pointer attachments, and it should just work. That's going to be, yeah, hard, and we'll probably need in the front end to remap it to the canonical expressions, and then, yeah, in the Gimplifier and OpenMP lowering to add the separate clauses that will do the mappings and pointer attachments. The second case is invalid because you're mapping two elements of the same array, which you can do only together, like an array section, or it has to be mapped before, because otherwise it would be separate mappings, and you can't do that. But you can do actually that with array elements. In that case, the implementation can choose whether it maps the whole structure or just allocates the whole structure and maps just those two elements, or it can rewrite the structure so that it's smaller and has just those elements. There are other examples. For C++ references, the implementation now needs to do the deep copies as long as there are no cycles. Like the last example is containing cycles because because A maps B, A references B element and B references A, and you can actually write it in C++, but you can't really implement it easily in the Gimplifier. And declare mapper is a way where you register for a certain type, aggregate type, some action where you either map the whole structure or just some fields from that, and plus some other actions, like you can attach some pointers or map arrays pointed from that, or and so on. And you can also give some identifier for the mapper, and you can have different kinds of mappings in certain cases.
Sorry, yeah, if we can go back to the previous slide about the deep copy. You can't have loops. What if you've got a DAG where a base node is pointed to by two different things? Do you get two copies of the base node, or do they both have to know the point to a single entity?
Well, there are limitations, but basically in a map clause, on the same construct, you can map the same thing several times, right, as long as it's the same thing, but you can map just different portions of that.
So sorry, that's not my question. My question is, if instead of the loop in the structure references, you had structure C had reference to B and to two B objects that both then reference the same A object. A diamond shape, thank you. Yeah, diamond shape. Think of a diamond shaped virtual base class hierarchy thing. Is that well defined?
That should work. Basically, what's disallowed is that while mapping types something, you need to map these and these and these types as well. And if the same type appears again, that the standard says that's wrong. During the reference mappings, so it's obvious that it will be a fixed set at compile time. What types can be mapped while mapping some variable.
Thank you.
So that's it from the changes in OpenMP. As I said, some features are already implemented, some features are partially implemented, other features are not done at all. So some of them will need to be pushed for GCC 10 and maybe later. And now let's discuss what we need to agree on, or
I have one question right at the beginning. You said that Fortran 2008 is now supported.
No, it's supported, but some features of the standard are not supported.
Okay.
Like, for instance, there was some attempt to define the co-arrays together, but I think it was rejected as a late addition, and it required too many discussions, and so co-arrays are not supported right now.
That would have been
they
my
will
question.
be in OpenMP 6 or 5.1 or something.
So at the moment, if somebody does co-arrays, OpenMP, well, it's either one or the other. I'm actually not quite sure.
Well, it depends on the implementation. I would guess that if you use co-arrays inside of the sequential code outside of the OpenMP regions, then it should be well defined and do something reasonable. But if you try to privatize a co-array or do something similar, then it's undefined.
Better to reject it outright then.
Yeah.
Yes.
I don't really have any specific things to raise up. Jakub, one idea that we were floating on, do you want to have an OpenACC maintainer? Like maybe for the OpenACC Devel Pass and some other OpenACC specific things?
I guess, yeah, that might be useful, sure. I know my patch review is lacking a lot. I'm sorry for that. I'd like to, have a look at the patches. In any case, just a final. Well, of course, some patches are clearly OpenACC specific and can't touch OpenMP, and in that case, that's as long as there is no useful sharing with OpenMP, then it should be something OpenACC maintainer could just hack it. Sometimes it's not clear that it's not affecting OpenMP, so we need to find out and make sure it behaves differently when it has to, and it's for OpenMP as well. If I make changes to classes, clauses, parsing, for instance, I should make sure that it doesn't affect OpenACC unless OpenACC standard uses the same thing. Well, a lot of the parsing is shared, so maybe in some cases, we need to make sure. But even until OpenACC maintainer is nominated, it's up to the steering committee, of course, to approve something like that. I really appreciate if other OpenACC hackers review the patches that other OpenACC workers post. I see sometimes you, sometimes Thomas and others post comments about the patches. I really appreciate that.
So I do have a question. So OpenACC has this OpenACC kernel thing where the compiler is supposed to do all the magic. Is there anything in OpenMP that is similar, and is OpenMP going in the same direction to eventually using early autopar and stuff like the OpenACC implementation?
Yes, that's basically the new loop construct where you just say the iterations are independent and you are at this level and you can do anything you want. And by anything you want, it means you can use the teams and threads and SIMD lanes, or you can launch extra threads or whatever. It's up to you to what actually you do. So
did you implement anything of that? Did you go
no,
okay.
Even not the parsing is done yet. I think initially it should be just look at the context and just lower it to the current region, current constructs, so multiple of them if any, and then perhaps add some extra clauses like auto that you can choose anything, and certainly we need for the middle end to, like we have the safe plan for loops, then we need some other flag that says the iterations are really independent.
But in that case, is the compiler still responsible for discovering reductions and privatization rules?
No, there are reduction clauses on the construct or private clauses.
So the compiler does not have like so much sophistication as a classic autopar pass.
Yes.
So I think there's maybe something related in Fortran. There's a concurrent thing which
it's
basically
like do concurrent. Yes.
Annotates your loop, and then everything gets mangled, and the actual Gimpel IL is not really anymore concurrent, but only the original source was, due to some implementation details. So I'm not sure how much care we need to apply when doing IL transforms to not violate the constraints set by like OpenACC kernels or OpenMP loop.
Yeah, we probably need to lower the reductions, which are the only way how you can reduce something in some way that the iterations, the middle NCs are really independent and not dependent on each other. And otherwise, we need to implement it easily somehow and then improve it over time.
I think with the Fortran case where I run into was like a local variable inside the loop was in Gimple, we just promoted it to function scope, and then it was no longer like private in the iteration, but global, and then you had...
I remember, and then we had to disable the flag because...
and we disabled the magic flag, which already exists on the loops for the graphite autopar thing, but that's a very short-lived information from graphite to autopar. So.
Yeah, we need to be careful on that. One thing I'd like to discuss is that the work you've done on the argument parsing, that's not fully done yet because I didn't like the libffi stuff. But so the way I'd like to see it is that we basically have some way to keep it in the IL, that it's possible to separate it. So either a structure with separate attributes or markups that you can break it up again in the offloading compiler, so that for PTX you could do one thing, and for the host or other targets that really think that the structure copying is itl, would just keep using that, or it can be the other way if we somehow manage to have multiple arguments and then put them together as one.
Can't you do it completely in the library? The decomposition of the struct if necessary.
I was thinking about doing something like GSRA and just like expand all the offloaded parameters if it benefits the backend, because that optimization does not help at all on the GCM port. So, you think that's feasible?
And another thing is what I'd like to, if you do it for OpenACC, it would be nice to get it working for OpenMP as well. There is one problem, I think, because we basically wrap the function into a wrapper which adds stack or something. So we would need to do some changes if you pass the arguments somehow as separate arguments to the CUDA kernel, then we would need to change what we actually emit and call what we do now in the wrapper, do it as a function call at the beginning of a function or something. So basically swap the wrapper with the kernel that calls the function initialized me now and do the rest afterwards. And then have a finalizer at the end of the kernel. But otherwise, I would hope if it really is that much faster to pass the arguments that way, that the OpenMP should benefit from that as well. And the problem is that my familiarity with the PTX stuff is very low. So I'd appreciate help from both you and maybe Alex as well.
So the cases that benefits is when you launch a lot of small little kernels or offloaded functions. But if you just have like a big matrix multiplication, then it won't help there. So one other issue that we occasionally get inquiries about is OpenACC and OpenMP interoperability. I know there's incompatibilities with the execution model with OpenMP and OpenACC. For instance, the OpenMP uses or treats the SIMD like a warp like a SIMD instead of having the other internal functions that OpenACC uses to do that at different levels of parallelism. Do you think there are any other incompatibility issues? At least calling offloaded functions from host OpenMP threads?
I'm not really sure how far we want to go with the interoperability. What we certainly need to support is that in the same program you use in one spot OpenACC and in another spot OpenMP. But otherwise, I think the nesting of stuff, well, some cases could be made to work, like if you have just host OpenMP stuff, and then you want to use OpenACC inside of that, like if you have an OMP teams, the host teams, or parallel region or OpenMP task, and you launch OpenACC inside of that. So we should allow that, and it probably shouldn't be that hard to support that. But inside of the offloaded regions, like mix OpenMP and OpenACC, it's something we should just reject, because neither of the standards specifies what happens in the other one, and specifying it what it means is going to be too hard. So either use this or use that.
So one other question I have is on admin. So as you know, with parallel programming, even though the standard says one thing, the compiler just kind of do something different. In terms of documentation, where's a good spot to say that you get better performance if you write your OpenACC programs this way? Would that fit in the GCC manual, or should that be like a standalone thing, or?
So I think putting it in some section in the user manual would certainly be good. I would like to have some GCC, well, tuning guide or whatever, like also for the vectorizer, tell people what to do, and more importantly probably what not to do. Yeah. When trying to write fast code, and like not try to switch optimizations on and off by individual thing like we always see when looking out in the wild. So definitely, if you have like a section on how to do target offloading with GCC in general, so what GCC supports well, what it doesn't support well, so where to concentrate the optimization work, it would certainly be appreciated.
So is that for internals, or?
No, I would put it into the user manual, because it's directed at the users and not at the developers, right? So at the GCC users.
But probably put it into the libcomp info pages. Or the other possibility is to start it as a wiki page, and when it's somehow complete, then copy it to the
I would say start writing it properly from the beginning.
Would be in the user documentation, because that's what users see easily. And trying to reference, say, go look somewhere else, but as Richard says, put it in extend.techie or a new section.
Okay.
I think we, for example, we have a short section about how to use LTO. Not just option documentation, but I think we have some meta information. Honza would probably remember, because I guess he wrote it. So it's something like that, how to use offloading in general.
But on the other side, information how to configure the compiler for offloading is only on wiki page and not in the...
But that's your fault. It's not to be supposed that way.
That's right.
So
yes.
Fix that.
So on the previous topic of passing arguments to offloaded code, I would recommend to build a structure descriptor that would describe the structure that holds the impact arguments. So for example, if you are passing 3 arguments, we currently just build the structure containing just those 3 arguments, but we can also build a second structure that describes the number of arguments and for each argument what type it is. And then libcomp can easily inspect that descriptor and build the proper call to the offloaded code. So that should not be too hard. But certainly some changes in the backend will also be needed, but that should not be a hard problem. And Can you also go back to the previous slide where the seamed if clause is described?
Which one?
Seamed if.
Yes.
Yeah, but certainly we do have something like this currently because we have if loop vectorized in the middle end, and for PTX offloading we also have an internal function that like decides between host and offloaded code. So how is that different from what we have now?
Right now it's not implemented. The parsing is done, and I don't use the clause at all. So the easy way to implement it is really to duplicate the loop and just guard it by this condition, and that is the minimal implementation. But the question is, of course, it would be better, especially for the code size, that the vectorizer gets this expression, or it's just a Boolean.
Does it have to be loop invariant? It can be loop variant, right? The condition.
No, it's some expression evaluated before the loop, so it needs to be loop invariant. And so basically, if the vectorizer has a way to see it in the middle end somehow through some internal function or something connected to the loop somehow, then it should be able to, whenever it does the loop versioning, to add this condition as one of the conditions it adds normally there.
Yeah, that is what I mean. So certainly we have the loop cloning for the for if conversion in the middle end. So we should be able to chain on whatever we need to the if clause that may already exist.
Yeah, we just need a way to stick it in the middle end so that it propagates from the OMP lowering through the inlining, which is going to be hard until, and all the optimizations until the vectorization. Yeah. If you have something like that, then it will work.
Yeah, we have that, and the way it works now, it binds by the seamed UID variable, because the seamed UID is a reference from the loop structure, and the loop structure is thankfully permanent. So it's, well, I think we have like all mechanism right now in the middle end to have that work.
So if you want to help with implementing this one, yeah, I think we are out of time now. So thanks for the discussions.